All right, when we're talking about chemical reactions, one way to make sense of this is by talking about cooking, or more specifically, making s'mores. If you are making s'mores, you know that you need 2 graham crackers, you need a 3-piece of chocolate because they come, that's 1/4 of a Hershey bar, and that's about the perfect size for a graham cracker, and you need 1 marshmallow. Put those together and you get 1 s'more. So if I want to make 2 s'mores, how much will I need? Well, 1 requires 2 graham crackers, so 2 is going to require 4 graham crackers. So 2 s'mores times my ratio is 1 to 2. 1 s'more requires 2 graham crackers, and that gives me 4 graham crackers needed. We call the number that we're starting with our known amount. So in this case, I knew I wanted to make 2 s'mores. I know that the ratio of s'mores to graham crackers is a 1 to 2 ratio. So I have put my s'mores, 1 s'more requires 2 graham crackers, and I'm making 2 s'mores. So I end up multiplying by that ratio of 2 graham crackers over 1 s'more. Now you'll notice that I'm using highlighters. I think that really helps in this case. So now instead of talking about graham crackers, we're going to talk about chemicals. If you read through the problem tells you that you have 12 moles of potassium chlorate. That is your known quantity. It asks us to calculate moles of oxygen. That is our unknown amount. So what we do is we start with our known amount, 12 moles. Just like here, our known amount was 2, and we multiply by the ratio. The ratio, again, is the coefficient. Our known amount goes on the bottom, our known coefficient, and our unknown coefficient will go on the top. So our known coefficient is 12 moles of KClO3. I should have written that. So the coefficient is 2 moles KClO3. And then the coefficient for the unknown is 3 moles of oxygen. If we do that math, we come up with 18 moles of oxygen produced if you react 12 moles of potassium chlorate. What we're doing is this is our mole ratio, and we get that from our coefficients. All right, the next question. The information that is given to us, that is known to us, we know that we're starting with 2.5 moles of potassium. All right, we want to solve for potassium chloride. So we start with what we know, 2.50 moles of potassium, and we're going to multiply by the number of moles of potassium compared to potassium chloride. 2 moles of potassium chloride are produced if you react 2 moles of potassium. So we'll put 2 moles KCl on top and 2 moles of K on the bottom. Now moles cancels, and we'll have an answer in moles of potassium chloride. 2 times 2 divided by 2, 2.5 times 2 divided by 2 equals 2.5 moles of KCl produced. The next one, let's identify what we know. We know that we are going to react 1.2 moles of sodium oxide. And we know that we want to figure out how many moles of sodium hydroxide that is going to produce. So what we're going to do, our known amount was 1.20 moles of sodium iodide. And we're solving for NaOH. So my ratio is going to be Na2O to NaOH. I have a coefficient of Na2O. I have a 1 in front of it. And I have a coefficient of 2 in front of sodium hydroxide. So we do that math, we get 2.4 moles of NaOH. The next one, we are told we have 16 moles of sulfur, so that's what we're starting with. And our ratio of sulfur to iron, because iron is what we're solving for, we can look up here. We have 1 mole of S8, and we have 8 moles of iron. So 16 times 8 is going to be 128 moles of iron that will be needed to react with the sulfur, the S8. All right, the next one. We've got 12 moles of sodium carbonate. And it's asking us to find moles of oxygen. So I start out with what I know. My known is 12 moles of sodium chlorate. There are 2 moles of sodium chlorate that react with 3 moles, react to produce 3 moles of oxygen. Once we do the math, we would be producing 18 moles of oxygen if we started with 12 sodium chlorates. The next one, we have 3.5 moles of silver nitrate. That is our unknown, or that is our known amount. Silver nitrate. We are solving for moles of copper. The ratio of silver to copper, we have 2 silver nitrate that will react with 1 mole of copper. And that gives us 1.75 moles of copper once that reaction is done. Finally, we have 25 moles of pure iron 3 oxide. Now, we're solving for moles of iron. So once again, if I stick with my color scheme here, I look at my coefficients. The coefficient in front of iron 3 oxide is 1 mole Fe2O3 and 2 moles of Fe. So therefore, if you have 28 moles of pure iron 3 oxide and it reacts with carbon, you're going to liberate 50 moles of iron. And that is mole-to-mole stoichiometry.